Hi, in this video we're going to talk about frequency distributions, and then we're going to create a frequency distribution. Now we're going to use a combination of methods, both our pen and paper and Excel, and you'll see that Excel can help us do things a little bit more efficiently. All right, so first of all, let's look over here. This is an actual frequency distribution. And what you'll notice about a frequency distribution is it has these ranges of values. Okay, so for example, the first range is 0.290 to 0.295. Okay, and each one of these ranges we call a class. Okay, so in this particular case, I have 9 classes. 1, 2, 3, 4, 5, 6, 7, 8, 9 classes. Okay, and these are the ranges of the classes. The other thing displayed in the frequency distribution is the frequency. So that's where the number comes from. And what the number displays is how many of my observations fell in this range. So for example, 3 observations would have been between 0.290 and 0.295. And we're going to talk about how we calculate that in a second. But before we do that, let's talk about the features of a frequency distribution. You will have what we call our lower limits. Okay, and those are the bottom numbers. So if we're asked to list our lower limits, we would say 0.290, 0.296, 0.302, 0.308, 0.314, 0.320, 0.326, 0.332, 0.338. Okay, so those are my lower limits, and I get those from these bottom numbers. And similarly, we can find our upper limits, and those are just going to be our upper numbers. So don't overcomplicate it. Lower limits are the lower values on our ranges. The upper limits are the higher values on our ranges. In other words, you can think about it as the left values and the right values. And hopefully you can type better than me. All right. All right, now the next thing we're going to talk about is our class width. And maybe you've noticed it already, maybe you haven't. But the difference between any 2 lower limits, for example, these 2, or these 2, okay, is going to be the same. 0.296 minus 0.290 gives me 0.006. 0.332 minus 0.326 gives me 0.006. So the class width is the difference either between 2 consecutive lower limits, or it also works to take the difference between 2 consecutive upper limits. The difference between 0.313 and 0.307 is 0.006. And the main thing to notice here is that it's always the same. We don't go 0.006, 0.007, 0.008. No, it's going to always be consistent throughout the frequency distribution. So any consecutive lower limits, any consecutive upper limits, no matter which 2 I pick, will always have the same difference. And that is our class width. Now this is probably the most missed question because students like to take the upper minus the lower, but that is incorrect. Notice if I take 0.295 minus 0.290, I get 0.005. That is not correct. I need to either use 2 lower limits or 2 upper limits. All right, the next thing we want to talk about is the boundaries. And the boundaries typically are just the midway point between upper limit and the next lower limit. So the midway point between 0.295 and 0.296 would be 0.2955. And it's also the value at which I quit putting numbers in one class and start putting them in the other. So for example, if I had a number over here in my data set of 0.2957, I would actually round that up because the 7 says round that up to 6 and count it in here. And the boundary tells me that anything from 0.2955 up to 0.29 6 is going to go in the next bin. So it's kind of where we stop putting numbers in one class and start putting numbers in the next. All right. And again, if that's confusing, think about it as the halfway point between here and here. And now we'd want to list these. And really, you're just going, if it's decimals, you're just going to add, go to the next decimal place and add a 5 on your upper limits. And the other thing is, keep in mind there's not just one, there's going to be a whole list of them. Okay. 0.3375 and 0.3435. Okay. And now the other thing I want you to realize is we also want to include the value that we would start using this lower value, and that would be 0.285. No, no, in other words, it's this minus 0.005, which is going to be 0.2895. Okay, so we want to also, we wouldn't put anything in this bin that was below that. And then you also want to go higher than your highest bin. Okay, so make sure you include these two. This is the common mistake there. Okay, so go the one below your lower bin and go the one above your upper bin. All right, midpoints is the midway point between these values. And again, you can calculate these basically by adding the two together and dividing by 2. So we can say equals this plus this divided by 2. Now my formula is not correct because of order of operations. So to get this to do it correctly, I need to put parentheses around my addition, meaning add the numbers together before you divide by 2. And you're going to see this a lot in Excel, that order of operations comes into play. So remember, please excuse my dear Aunt Shannon, and parentheses first, so it will do this first, then it'll divide by the 2. Otherwise, remember, division comes before addition, so it would divide by 2 before it added, and that's not what we want. So our first midpoint would be 0.2925, and you can notice that it is the midway point between here and here. And actually, I think if we just do this, no, it's not going to do it that way, but if we drag this down, it will continue and do all of them for us using that calculation. Okay? All right, so these would be my midpoints. All right, now that we've established the key terminology, lower limit, the lower values, upper limit, the upper values, width, the difference between two classes, boundaries, the point at which I jump from one class to the other, and then the midpoints, the middle part of each class. We're ready to use our knowledge and try to construct a frequency distribution. So we're going to try to construct this. All right. Now I'm going to jump to my pen and paper to do that. Probably the number one question is, Shannon, how do I determine my class width? And there is a rule of thumb. I would not call this a hard formula that works every time. It is simply a rule of thumb. So the rule of thumb is take your max value, which in this case was 0.343, minus your min value, which in this case is 0.290. Now make sure your data is in order if you're just taking the first and the last. Otherwise your max value could be right here in the middle. So look for your largest value. That's what we mean by max. Look for your smallest value. That's what we mean by min. And then the number of classes. I'm a big fan of 8. Okay, but ideally we want to use between 5. Anything less than 5 is too few, and I'd say 20. But again, this depends on how many data points you have. Actually, 8 is probably a lot for 15 data points, but I like 8, so we're going to use 8 because I'm going to use it for something else. All right. All right, so then do your math again. Do your subtraction in the numerator first, 0.243 minus 0.290, and then divide by your 8, and we get the nice round number, of 0.06625. And now I do not, let me repeat that, do not take this entire number or you'll drive yourself crazy. Who wants to try to calculate these numbers out to 6 decimal places? All right. So we know that my data is out to 3, so it's going to be perfectly fine to go out to 3. And now I chose a class width when doing this of 0.006. Now you might say, well, why didn't you choose 7? I sure could have. If I'd have gone up, I'd have probably ended up with fewer classes. If I go down, I end up with more classes. So the Shannon philosophy is more is better as long as we're not up here in this 20 range. But if you want to use the 0.007, that is perfectly fine. Again, this is a rule of thumb, not an absolute. And if you notice, I used 0.006, I ended up with 9 classes. Okay, so my class width is 0.006, and I'm going to want to start with my lowest number that will start my first class. Okay, so I'm going to start my first class with 0.290. And I know my class width is 0.006. Okay. All right. So what I'm going to do is clear this out. Okay. And show you how I can construct it. All right. So I'm going to start with my low number, 0.290. And remember, the class width tells me how much higher the next one should be. So it's going to be equal to this plus 0.006. All right, and now I can use the Excel feature and just drag until I get down to where I need to. Okay. So how do I get my first upper? Well, if this is 0.296, what's the next number down from that going to your last decimal place? Well, it's 0.295. Okay, and what do we know about the class width? Well, it has to be the same. So this is going to equal this value plus 0.006. And so you can see, and again, you can double check this, 301, 302. They're sequential, so I'm doing it right. And how did I know to stop here? Well, my largest value is 0.343. It would fall in this bin, so I'm good to go. If I had stopped at 0.342, I'd have had to create another one to make sure I could include this value here. Okay, so again, that is our rule of thumb for constructing our lower and upper ranges of our classes. Use this formula as a rule of thumb. Don't be afraid to round up or round down. And then start with your lowest number and add your class width to it to get your next lower limit. Okay? Don't add it this way to get your upper. Go straight down. Okay? And then you can pull down. All right, so now how do we come up with these numbers here, the frequencies? Well, that's all about classifying our data. So if I have this data set here, the way I like to think about it is I've now, by creating my classes, created buckets. And this bucket goes from 0.290 to 0.295. Notice that these labels correspond to this, 290 to 295, 296 to 301, 296, 301. And now what I'm going to do is go through every single one of my data points and classify it into, or put it into the bucket that it falls in. Another way to think about this is if you ask your kids to pick up their toys and you had a red bucket to put all their red toys in, a blue bucket to put all their blue toys in, a green bucket to put all their green toys in, your kids could certainly do that if they know their colors. And that's what we're doing with this data. I have 0.290. What bucket would that fall in? Well, this is too high. All right, I see that 290 ranges here, so I'm going to put it in that bucket. And then I go to my next data point, 0.291. Oh, that's going to go in this bucket. I have a 0.291. And notice that they can repeat. That's fine, but you want to account for it as many times as it repeats. So this repeated twice, so I want 2 of those in my bucket. Okay. 0.298, that's going to go in this bucket. 0.3 is going to go in this bucket. 302 is going to go in this bucket. 308 goes into this bucket. Let's see, 309. 315 goes into the next bucket. 320 goes into this bucket. So does 322. All right, and so does 324. 331. 338. Nope, doesn't go into this one. It goes into this one. And 343. And notice that it's perfectly fine to have an empty bucket. All right. If I stop my frequency distribution here, I have nowhere to put these guys. So I want to make sure that there's a bucket that I can put everybody in. Okay, so you have to continue your classes or your buckets until you get all the data included. Now, to determine the frequency, I simply count how many items are in my bucket. 1, 2, 3. 1, 2. 1, 2, 1, 3, 1, 0, 2. And these are the numbers that go into my frequency distribution. So we would have, if you notice, these numbers should correspond to these. 3, 2, 1, 2, 1, 3, 1, 0, 2. And that's where the frequencies come in. In the next video, we will talk about how to graph this using a histogram. So the table that we created is called the frequency distribution table, and it consists of your classes and your frequency. The graph of this data is called the histogram, and we will create that in our next video.
Frequency.